Right. Hello, everyone. Once again. Hello, once again. Today, after the last session that we did, where we introduced the physical layer, today we focus on the data link layer. And as I said yesterday, after module number 3, protocols and models, where we discussed the OSI model, we introduced every layer of the model and its function. With following modules, you see that we basically go into every layer and go a bit into detail. What is the function of all those layers? We started with the physical layer. I think we dealt with a couple of things, mostly the physical cabling of the network, where we have our transmission. We define that as the foundation of communicating via networks. So we have our physical devices, we have our physical cabling. We talked about encoding. We talked about copper, UTP, STP. We talked about signaling. With signaling, we talked about electrical signals, fiber, light pulses. Then we have radio waves, microwaves, electromagnetic waves. I remember also talking about electromagnetic interference, but that was the physical layer. The layer above the physical layer, we have what we call the data link layer. And its main responsibility is ensuring successful data transmission across the physical medium. So depending on what the type of medium that we have on the physical layer, the data link layer is responsible for the successful transmission of information between two devices. So this layer also acts as an intermediary, preparing data for specific characteristics of a chosen medium. So you see the way data is prepared if our medium is fiber is going to be different to the way data is prepared if our media is copper, for example. So different types of mediums means different types of preparation of the data that we have so that it is better suited to be transmitted. The data that we have from up the layers, the OSI model, from the application layer, presentation, session, we all have that information coming from up all those layers, getting encapsulated. We're adding headers, we're adding trailers. But most of that information is not transmissible via our channels. There is a certain type of format that is required to be transmitted over our channel. So after all that baggage that we have from the upper layers, when it gets to the data link, that is when all that data is prepared to be transmitted. That is the main responsibility of the data link layer, right? So we have different types of media, meaning different adaptations of the data to be transmitted over our physical medium. So I think that's the basic introduction of what the data link layer does. Other functions, obviously, including framing. Uh, Another one important function, MAC addressing. Addressing our information using the physical addresses that we call the MAC address. We'll get into that. Right, main objective of this module is to explain how media access control in the data link layer supports communication across networks. And we're going to be looking at the purpose of the data link layer, also look at the different type of topologies that we have, obviously relating that to the data link layer. Why is it important that we know the type of topology that we are dealing with? I think it was in chapter 1 where we introduced topologies, the physical and the logical. In this chapter, we're going to be looking at how the setup of a network, the topology of a network, influences how data is being prepared in the data link layer. And lastly, we'll look at the format of the data link frame, the number of components that we have on that data link frame that we're going to be looking at, and explaining every function of each and every component of that frame. Purpose of the data link layer. I think I've quickly summarized the purpose of the data link layer with my introduction, being responsible for communication between end devices and the device network interface cards. It allows upper layer protocols to access physical layer media, and encapsulates layer 3 packets, which are IPv4 and IPv6, into layer 2 frames. It also performs error detection. That's very important. Error detection, and rejects corrupt frames. So number one, the data link layer enables communication of the NICs of different devices on the same network segment. Very important, on the same network segment. So if we are on the same network, we define the same network at this level by an interface coming from the router. This is our network. So if I have a device, let's have my switch in here, two devices, PC 1 and 2. These two PCs are on the same network segment. Therefore, they can communicate at layer 2. And the data link layer is responsible for that communication. We also have another type of communication where we are not on the same segment. We have another PC 3 and 4. If PC 3 and 1 are trying to communicate, we are no longer on the same segment. That's why we go and use a layer 3 addressing, because layer 2 addressing doesn't get to that level. Remote connections, layer 3. Same network segment, layer 2, very important. So as long as I'm in this segment, I can communicate with whatever device that is in this segment. And if I go remote, that's a problem. MAC address does not work for remote connections. It only works for local connections. So the data link layer is responsible for enabling communication of the network interface cards of different devices on the same network segment. This is very important. Right. It also translates data from upper layers into a format that is suitable for transmission over a specific physical medium. Translation, it sort of translates data from the upper layers, right? So when we talk of the upper layers, we talked of the application layer. These are the upper layers. We talked of the presentation. Let me just say plus presentation, because this is usually bundled up as the application layer, plus the session layer when looking at the OSI model. Then we have the transport, we have the network, the data link, then lastly the physical. So when we say it translates data from the upper layers into a format suitable for transmission, that format is the frame. From up here, the PDU, I'm sort of repeating the things that we did in the last session. The PDU for the application and all the upper layers from the session, presentation, application is data. It gets encapsulated. So we add a header plus the data that we have, then a trailer. This becomes a segment in the transport layer. Right? This becomes the data We add a header plus a trailer. What is this? This is now a packet. This now becomes the data. We add a trailer and a header. We are now at this layer. This now becomes the frame. At this stage, where we have the frame, this is the preparation of data from the upper layers so that it is best transmitted over a specific channel. Depending on the type of channel that we have, you see that our frames will not be the same. We'll discuss the frame structure, and you see that it's not the same because we have different types of media. Part of the frame, some of it has a lot of overhead. The headers and trailer, there's a lot of information there. Why? Because of the different types of media that we have. Now, going back to my point, it translates data from the upper layers into a format that is suitable for transmission. That format is what we call a frame. So when you get to layer 2, we have what we call data framing, which is basically a translation of whatever that we had from the upper layers and the frame. We translate all that data into a frame, which is then translated into bits at the physical layer. Then the bits are translated into a signal. It can be an electrical signal, it can be light pulses, depending on the type of media that we have. So this is at layer 2, then this is at layer number 1. Right. Then let's talk error detection. The data link layer also detects, also includes mechanisms used to detect errors, identifying and also rejecting corrupted frames, therefore ensuring that only valid data is passed to the higher layers, right? So traffic, when we talk of encapsulation, we have data coming from the upper layers going down, right? This is where it's very important, data framing. This is where data framing is very important, right? Preparing data for transmission. But if we are receiving, here at this stage, we have our bits, then we have our electrical signal, electrical over copper, electrical signal over copper, which is being transmitted. So this is device A, device B. Our signal is being transmitted over copper. When it gets to this point, what happens? We start going up the layers again. So at this point, the electrical signal is converted to the bits. This is converted to the bits again. Then the bits, they go up the layer. The headers and trailers are removed at the data link layer. When the headers and trailers are removed at the data link layer, we have another bunch of 10s, which are used to detect if we have an error in the message. So if at this layer an error is detected, it's either the whole message is dropped or a response is sent that we have an error, this packet it has an error, or a couple of segments are not there. This is where it happens. So within the frame, I want to go back a little bit. Within the frame, here we go, we got our bits up to the second layer, de-encapsulation. De-encapsulation, the removing of the headers and the trailers. When we remove the headers, when we remove the trailers, what do we see in that information? We see a couple of bits which are used for error detection. So if those bits, let's say, if when I was sending my information, I had 101, used to check if our information has an error. If I still have 101 this end, it means my information is correct. I'm giving an example. But if you now have 100, the error code, might mean we have a problem. So it means a message is sent back. We need to retransmit our information because there are some errors. What layer is responsible for that? Layer number 2 is responsible for error detection. Why? An error needs to be detected early before risati rasvika kumusoro kuno. Mukaita error kunoku and you allow decapsulation kusvika kunoku. That's why we don't even see the message because ikasvika ku-application layer, we can now see the message as us as clients, as humans. We can now see the message. Ndopa munoona message rine ma-error, and what use do you have a message nema-errors? Nothing. So riri kuzasi kuno ndo panodetectwa ma-errors and all. So a number of things that I've explained that summarize the functions of the data link layer. Number one, communication at layer number 2 within the same network segment. The data link layer is responsible for that. Communication within the same network segment. Number 2, translation. Translation of upper layer data into a format that is transmittable over a specific type of medium. That's number 2. And number 3, error detection. Very simple. I've put much emphasis on this because typical exam question, you are given a list of functions and you have to choose. That's a multiple answer question. You have to choose 3 functions of the data link layer. So you need to have an idea what the data link layer, not only that, but every other layer in a network does. Right. We now look at the data link sublayers. So you see the data link is divided into 2 sublayers. We have the ALC logic link control and the MAC access control layer, sublayers. The ALC communicates between the ALC sublayer communicates between the network software at the upper layer and the device hardware at the lower layer. And the MAC sublayer is responsible for the data encapsulation and media access. All right. The ALC acts as an interface between the higher level software, the higher level networking software, and the hardware components of the lower layers. So you will see from a layers A to 7 layers A of the OSI model. I think I gave a brief explanation of this. And I said the application layers, the layers at the top, let's just call them, all of them, the application layers. These are software guys. Because those upper layers is all software. Developers, software engineers, that is their playground. As we go from, I think the transport layer, that's the middle ground. I think everyone can play around that area. But as we go from the network layer down to the physical layer, this is mostly hardware. Starting here, our hardware is a router. Then at layer 2, we have a switch. Here we have our media, our cables, everything. So it is all hardware. Now, what acts as an interface between the software at the upper layers and the hardware at the lower layers? This layer, the logical link control, acts as that interface. And its main responsibility is the translation that I've mentioned. It translates information between layers, ensuring that the higher level protocols can communicate with the underlying hardware. And this regardless of the type of network technology being used. Kuzasi kuno tinokwanisa tine different types of network technologies. Perfect example, different types of media. Uh, where do I write? So these are upper layers, right? Here we have our lower layers. And I was saying it acts as a translator for the higher level protocols so that they can communicate with the hardware, regardless of the technologies that are being used. Kuno tinokwanisa tine different types of technologies. For example, munhu agadzira web page rake kunoko, he does not have a need yekuziva kuti traffic yake yeweb page yake paichaitwa routed ichashandisa MikroTik here, ichashandisa Cisco here, ichashandisa Y here. It does not have to think about that. And the reason why it does not is because of this layer, because it does all the translation. Saka kana tiri kushandisa Cisco device, that layer translates every protocol from the upper layers so that it is fit for the technology iri kushanda ipapo. I think I've tried to be as clear as I can. So the logical link control, its main job, translation, making the hardware understand what the protocols are saying, what the software is saying. Even if you have different types of vendors, different types of media, there is a layer which is responsible for having the softwares being understood by the hardware. That is the ALC. Then going to the MAC. The MAC is responsible for data encapsulation in what we call media access control. And what is data encapsulation? Adding of the headers and the trailers. And one of the important things that is in the header, we have the MAC address. I think that's why it's called the MAC sublayer. So this one is responsible for encapsulation, data encapsulation, adding headers and trailer, most importantly, adding the source MAC address and the destination MAC address of the frame. The MAC sublayer also does error checking. The error correction, error detection that we were talking about in the previous slide, this is where it is done in the MAC sublayer. So I think in the previous slides, we're sort of summarizing everything, grouping everything, the translation, the error detection, the encapsulation. We just said that's the responsibility of the data link layer. But now we have separated the data link layer, split. We now have the ALC and the MAC, and they have their separate responsibilities. Very important. You will definitely be getting questions on the comparison of the MAC and the ALC. And the easiest one, you have to understand this is for translation, software/hardware. Translation between software and hardware so that the hardware understands what the software is saying. Then this one is responsible for encapsulation, data encapsulation, adding headers, adding trailers, MAC addressing, error correction, detection, and basically those are the sub layers that we have. All right, providing access to the media. Packets exchanged between nodes may experience numerous data link layers and media transitions. Okay. At each hop along the path, a router performs 4 basic layer 2 functions. It accepts a frame from the network medium, de-encapsulates the frame to expose the encapsulated packet, re-encapsulates the frame into a new frame, forwards the new frame on the medium of the next network segment. Right. So what are we talking about here? Let's say we are sending we have a switch. Let's start with a switch. I want to send, this is the same network segment, same network. I want to send information from PC number 1 to PC number 2. I'm going to take you through the process of what happens to the frame or the whole OSI model from the upper layers to the lower layers. If I'm trying to send information from device 1, I first interact with the upper layers software, user interface, right? Our graphical user interface or our command line interface. That's how we interact with the system. From the upper layers, data gets encapsulated up until we get to the physical layer. When we get to the physical layer, let me focus on layer number 2 as well. At layer number 2, what happens? Data framing. And when we talk of data framing, the most important thing I want to highlight is adding of the source mark and the destination mark. The source defining where the message is coming from, which is the address of 1. The destination defining the MAC address of device number 2. So from the upper layers going down, at layer number 2, which is our focus of the day, we have data framing, where during encapsulation, we add headers and trailers. In the header, we have the source and destination mark. Right from there, we go to the physical. In the physical, our frame is converted into bits. Our bits are converted into a signal depending on the media that we have. If our media is, in this cable, is definitely copper, Ethernet. Our media is copper. So we have electrical signals at this point going into our copper to our switch. What happens when the message reaches the switch? A switch is a layer 2 device. It takes the information about device number 1, starting from the lower layer, because we started the physical layer. So we started the physical, here the physical, we go to the application. So starting at the physical to the application, we start going up. But with the switch, since it's a layer 2 device, we don't go up to the application layer. We end somewhere right here where there is layer 2. That's a switch for you. So from the physical layer, as we start going up, our signal, which was electrical, is converted into bits. Then our bits, when we do de-encapsulation, we remove our headers and trailers. And at layer 2, in the header and the trailer, that's where we see the source and destination mark. The switch compares, looks at the destination, if I can say, looks at the destination MAC address and looks at its MAC addressing table. The MAC addressing table is sort of a directory. Mafoni ekudhara wangona chibhuku changa chine phone number evanhu vese. The MAC addressing table is sort of that same thing. It has the addresses of all the devices in the network. All right, so the MAC addressing table is sort of that phone directory where you have all the addresses. So at this point, switch checks kuti destination mark ichi, and it checks in its directory kuti destination mark irimo here. Kana irimo, it means we can easily reach that device. Therefore, switch robot ratoziva kuti information iyi inofanira kuenda kudevice number 2 because it knows from the directory could address the device number 2. So decapsulation, our switch looks at the destination MAC. Okay, our destination MAC address is proper, meaning we have, there's a hand up, just a minute, meaning we now know what should our information. At the switch directly forwards information to device number 2. If we had another device panel, device number 3, since the destination mark is not pointing at device number 3, the switch will not forward to device number 3. it just forwards to device number two. And this is what happens when we are switching. I've basically explained what switching is. So in summary, switching is device number one coming from the upper layers up to the lower layers, the physical layer, takupinda mkopa, tapanapa, kopa yesienda kuenda uko. Yasvika pa switch removes maheaders nematrailers, and it looks at the information iri mumaheaders nematrailers. The information inobva yataura kuti the destination address address yakati. That address, if is in the MAC addressing table, then your frame is forwarded to that PC. Then kana frame raforwardwa kuuya kupc number 2 parinosvikira panapa rinosvikira paphysical layer, but tichida kuona kuti data rasvika ichii, so we start going up the layers de-encapsulation, but this PC rinokwanisa kusvika kuupper layer yeapplication. Switch rinogumira ipapo palayer number 2. So this one takes the physical signal ratinaro, it removes maframes tamulayer number 2, tobva taona kuti address yedu yakafanana neaddress iri mudestination mark, tosimudza kuendesa kuma-upper layers, tobva tapinda munetworking layer. Possibly we don't have my IP addresses because we are using my MAC address, okay? We are not connected to the internet, we are not communicating over the internet. Tokwira topinda mutransport, transport yecheka zvairirocheka, topinda musession, topinda mupresentation, patinosvika kuapplication kwekupedzisira. If we had sent a message, an image, this is where we see our image in the application layer. All right, question. Someone was raising a hand. You can unmute. Black Russian, I think. You can unmute and ask your question.
Yes, I wanted to understand something. Let's say we are connected to internet, right?
Yes.
Then PCA sends a message to PCB who's on a different network. And during the encapsulation process and the de-encapsulation process, when the message arrives on PCB from the physical layer, and it gets to layer 2 where there is a switch. Then how does PCA, how can I put this? How does the switch on network 2 understand the IP address that is coming from network 1?
Okay, let's design a typical network. Hopefully we get network here I will describe. So network yako probably is looking something like this. Right?
Yes.
This is PC1, this is PC2. All right, 3 minutes, 4 minutes. Let me just go through the communication process and hope you get answered along the way. Right? If I'm sending information from PC1 to PC2, here we are not in the same networking segment, same network segment. It's a remote. Here we have a remote connection. If we have different networks, it means we can no longer send information using layer 2 addresses, only layer 2 addresses. There is now need yokushandisa my IP address because of my networks are different. So information yedu iri application layer iri kubva pa PC number 1, image ratoda kusenda mupresentation, image redu rocompresswa. Musession, we initiate our dialogue. Mutransport, toita segmentation. Patinosvika pa-network layer ndopadotangira. Patinosvika pa-network layer, ma-IP address akutanga kuiswa. The header ratinoedhera pa-encapsulation tichidzika down ma-layers. Patinosvika pa-network layer, that header rakuiswa ma-IP address. Rakuiswa the destination IP address, which is the IP address of this, and the source IP address, which is the address of this. Then parinodzika tam layer number 2. Layer number two, source MAC address yovela square this PC. The destination MAC address square this default gateway. I think we did this, we discussed this. Right, it should be chapter 3. I think we discussed this. Right. So because layer 2 addresses, they don't go outside the network. That's why layer 2 address here by default gateway. Right. So tam layer number 2, tam data link. But not Zika, physical, we know what happens on physical. Then it means that pin physical cable here, information radio shika up. At this point, I'm no longer looking at the switch. Let's keep the switch. And the information radio shika route. Yes, you got a router. Router starts de-encapsulation. De-encapsulation, we are now going up my layers. From the physical, router ready no kwanisa visa ma headers epa layer 2. Router sama MAC address. Yona kuti MAC address iripo MAC address ye interface re router ero. So it means that information was destined for the router. That allows router to take matters up to another layer. Kana address iyoyo yakasiyana ne-interface riri router, the router will drop that packet. That information will be dropped, right? But since it's the same, it means takwidza kuenda layer number 3. Router o rinogumira layer number 3 harikwire kuenda musoro, right? But unopinda layer number 3, the router looks at the IP address. The IP address kana iri in the same network, the router looks at the network ID. The network ID will direct it to network iri kunoki. So router parinotanga kuita re-encapsulation frame yedu, it moves it to this direction. Right. I see I have a minute. Let me continue explaining this in the next video.